This is a basic dividing head whereby one turn of that gives a 40th a turn of that, 40 to 1, so it takes 40 turns of that to give one rotation of that. The trouble with this is I can't get 63 teeth out of it. I've got all the index plates for it, it just doesn't happen. You need a compound dividing head. So what I did, at least what a friend of mine did, he machined that plate for me. That's got 63 holes in it, and I made a little jig to go on the end of there, and all we do is we'll put a dowel pin through there like that, and then we'll turn the handle until it lines up, lock it up, machine a gear, machine a tooth back out, and then we'll turn it till the next one goes in, which is there, lock it up, machine a tooth till we get 63 teeth. Very laborious, but it does work. So that's how I got away with using the ordinary dividing head. Fortunately, I have got all the little bits and pieces to hold the gear in place. We'll set it all up. I'll show you the various stages of setting it up, and then we'll try and get this gear cut. I've got the dividing head clamped down. That face there is at 90 degrees to the machine. I've got the cutter in. The cutter's going to be going in that direction, so it's going to be pushing the job towards that, which is the strongest part of the job. And the cutter is dead on centre height. That's really important that the cutter is on centre height. See there, it's right in the middle. It looks off with the camera, but when you drop down to eye level down there, it's absolutely spot on centre height. Now we need to mount the job between centres and make sure that the job is also at 90 degrees to the bed of the machine. Right, so we've got the job mounted between centres, and those two centre heights are exactly the same height, because I did check. I put a little bit of weight on the tailstock centre. I'm going to lock it up. So that now is fastened between centres. We use a square just to make sure the job is nice and square, but with the centre heights being right, it can't be anything else really. Absolutely spot on. You could run the clock up and down there, but you don't need to. It is square. Now we need to lock the job onto this face plate, and I'm going to use a layer driving dog for that, clamped in between those two little clamps there. I'll get that done, and I'll come back in here. It's a little bit Heath Robinson looking, but it does work. Or at least it did work probably 5 or 6 years ago when I cut the gear for the lathe. And so that locks onto there. Come on, John. And then that's locked in between those two teeth there, and that's what holds it all together basically. Right, a little bit tightening up done. I remember now I actually hit the head of that bolt with a cutter when I was cutting one of the teeth on the smaller gear. I remember now. It's all sort of coming back to us. It's obviously imperative that this doesn't move once you start cutting the gear. It's going to be all locked together. Get those two up together, and then make sure everything's nice and tight, so nothing can move. Right, and this needs locking onto that most taper sleeve which is in there. So basically that's it now, kind of ready to lock off, touch the job off and cut one, basically cut a gear, or cut a tooth. Everything's rigid, it can't move. Well, we hope it can't move. There's a locking pin coming through the back plate, you can see it there. So it's kind of getting near ready to cut the first tooth now. I've got the height of the machine locked off. I'll bring the camera around so you can actually see the cutter working. Right, we're ready to touch this off now. And gently bring it out and just take it in, it just touches. That's it there. The depth of cut is 147 thou, which just happens to be the maximum snooker break. I'll convert that to millimetres just for ease. 3.75 mil. You should take that in one go, I would imagine. So we'll dial in 3.75. We'll do a 1.5 mil cut just to see what it looks like. It's not going to do any harm. Cutting that no problem. So we can go with a full 3.75. Right, so that's the first tooth done. Index round 1 division now. We can so you can see what's going on. Hopefully you can see the pin there. Right, so we take the pin out, loosen that off, and go around one hole till the pin drops in, like that. That's it, that's a pin through, lock it off, we're ready to cut tooth number 2. I'm cutting it much easier than cut the hardened steel gear I used on mine. Right, so that's the first tooth proper, and it does look good. We'll index it round 1 more. That's it there, pin nice and free, and it just carries on like this until we get 63 teeth done. And as far as cost, it's got to be £1 a tooth, it's got to be the amount of time and effort I've spent on this. If anybody wants a one, don't ring me. This is the last one. Oh, you clumsy bastard, John. Nice. I'm a little bit excited there, a little bit carried away. That's the gear done. The mesh together, no problem. 63 tooth gear wheel. Like I say, mine's made of steel and mine's noisy. This one should be nice and quiet. Like I say, with it being fibre, if you make a mistake, all it does is simply take the teeth off this instead of causing any damage. There's one tooth there that I caught, that was the last one. I did that because I'm an impatient bastard. Not to worry, there's still plenty area for it to drive on. Once again, it's just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do. I'm now well over 100,000, but it's important that we carry on subscribing. Anyway, thanks for watching.